This is the Unit 2 review. For problems 1 through 4, given the system of equations, determine the possible number of solutions. Is there one solution, no solution, or infinite? So the way that we do that is we're going to compare the two equations. These are set up in y equals mx plus b form. Both equations are. And if you were to look at the slopes of both, that's the most important thing to look at. And they're both 3. That means if you graph it, they're both going to go up 3 over 1, but they don't start at the same point. The first one starts 1, 2, 3, 4, 5, 6, 7, 8, up 3 over 1. The other one starts at 1, up 3 over 1, and so they end up being parallel, same slope, but different intercepts means no solution. There's no point that they have in common. This next one, number 2, if you look at the slopes, 2 and 3, they are different. Anytime you have different slopes, you're always going to have one solution. Doesn't matter if they start at the same intercept, the slopes are different, one solution. This one, we can compare 1/2, but we don't have the slope on the second equation because it's not of the form y equals mx plus b. So we have to solve it for y, and if you do that, we have to move the x over, so we'd add x. I'm going to put it on the side because they're not like terms. And then we would divide out 2 everywhere. So 2, 2, 2, which would leave us with y equals 4 divided 2 is 2. And there's a 1 with the x, so it's really 1/2 x. And the 1/2 will just stay there. So if you look at this, we've got same slope, but they actually start both at 2. These are the exact same equations. They have a y-intercept of 2 and a slope of 1/2. Same equations, infinitely many points in common. So infinite solutions. And this one, again, if you check the slope, the first one is -1 and the second has a +1 slope. These lines will cross and you will have one solution. Anytime slopes are not the same, you will always have one solution. Number 5, what is the value of x in the following system of equations? If you notice, yes, we could subtract the 4 and get both of these to be y equals mx plus b. And then you could just graph them, and that would work. However, because there is a variable all by itself, all alone on one side, the easiest thing to do here, graphing's pretty easy too, but we can use substitution. So we're going to take what y is equal to and plug it in for y on the other equation. So take the y out and replace it with 4x minus 4. So you got 4x plus, I'm plugging in the y, which is 4x minus 4, equal to 12. Technically on this one I don't need the parentheses, there's nothing to distribute. So the x's are on the same side of the street, you combine, you do what it says, and it says add them. So 4x and 4x make 8x minus 4 equals 12. And get our 0 first, add 4, 8x is 16, divide out 8x is 2. Notice the problem says find the value of x. We don't have to find y because it only tells us to find x, and we already did that, so 5 is done. Cell phone company A charges $25 access fee per month plus $10 per minute. This could be a little bit confusing, but because when we're writing the equations, we're writing the cost of each month. it says we pay 25 access fee one time in the month. So per month, one time in the month. So we would say the cost is equal to $25, and we pay that one time in the month. Plus, it tells us to put a plus, 10 cents per minute. That is the total cost per month. I should have written that more clearly in the problem. Cell phone company B charges $50 per month. Again, we are finding the cost of the month, so we just pay 50 one time during the month and plus 20 cents each minute. And it just says write the two equations, and that's what this is. And we're done with 6. You are planning to go to the movies. You have a choice of 2 packages. You can get 4 tickets and 2 bags of popcorn for $20, or 6 tickets and 6 bags of popcorn for $36. Find the cost of the popcorn. So this is really set up pretty straightforward. 4 tickets, 2 bags of popcorn is 20. 6 tickets, 6 bags of popcorn is 36. So here we could times by the 4 and the 6, or we could times by the 6 and the 2. Either way is fine. I don't know, maybe I'll just do 6 and 2 because they're smaller. So you switch 6 and 2. This is set up for elimination, so that's what I'm doing right now. And if I multiply the 6 through, I got 24t plus 12p equals 120. 12t plus 12p equals 72. And then from here, now that we have our numbers the same, we need one of them to be positive and the other to be negative. So if we change the sign here, we have to change it here and here. Now we can add these together. So this is 0. 24 and negative 12 is 12t. 120 take away 72 is, let's see, 28 plus 20 is 48. And you divide out the 12 and we get t is 4. So it's 4 tickets, but we wanted, the question says find bags of popcorn, so I'm going to put 4 back in for t. 4. I'm putting it in the top equation, so I picked this one. I'm going to plug it back into 4 times 4. T is 4. That's what we just found. And now I'm going to solve this for p. 4 times 4 is 16. So minus 16. And divide out 2. So it is 2 bags of popcorn as the answer. You are going bowling. 6 games, 3 pairs of shoes cost you $24.50. 4 games and 4 pairs of shoes cost you $18. This one is pretty much set up for you again. $24.50 and 4 games plus 4 pairs of shoes is $18. So here we could take 6 and 4, or we could use 3 and 4. Again, this is set up for elimination, so I'm going to do 4 and 3 because they're smaller than 6 and 4. So 24g plus 12s equals 98. 12g plus 12s equals 54. And from here, we need one of the 12s to be positive, one of them to be negative. And again, it doesn't matter which equation. I'm going to just do the bottom one, change all the signs there. So 24 12 is 12g. This is 0. We've eliminated that. 98 minus 54 is 44. If you divide out 12, it's actually a decimal. But since we're talking about money and the price of each game, I'm going to round it to 2 decimal places. And so the price of each game is about $3.67. And if you plug that back in for G, I'm going to use the bottom one then this time. Plug it back in for G. 367 plus 4S equals 18. Multiply 4 and 367. So I got 1468, and then we're going to subtract 1468 on both sides. 868. And here we got 0. We got 4S equal to $3, or sorry, I'm not talking about money, 332. Actually, it is talking about money. Divided by 4, both sides. So S is equal to, in this case, 83 cents. So those are some cheap running shoes. Next one, number 9. You want to have a birthday party at Fiesta Fun. You have a choice of 2 packages. Package A, $4 per person for rides, and $20 for a birthday cake. $4 per person plus $20 for a birthday cake. Typically, people only have one birthday cake, so it's just $20 for the cake. You don't have cake. You just have one. And that could equal your total cost. Package B, you have $6 per person, and the cake is included, so you don't have to pay for the cake. So this is just equal to your cost. How many people will the 2 packages cost? So for how many people will the packages cost the same amount? So if we plug this, notice that this is solved for C. C is by itself. I could have picked the top one too. This one is really set up for substitution. So C is by itself. 6P is equal to C. So we really can take this C out and put in its place 6P. So we're left with 4P plus 20 equal to 6P. And to solve that, you want your P's on one side and your numbers without P's on the other. So let's move 4P over so that 20 can be by itself. And so then you'd end up with 20 equal to 2P, and divide out 2. So the P is 20, which in this case means people. 10 people you can invite, so that the 2 choices, the 2 options you're given would be the same amount in price. Number 10, solve the system with elimination. So with elimination, we got x's lined up, y's lined up, numbers lined up. And then you can either use 6 and 5 or 4 and 3. Again, I like to use the smaller numbers. So I'm going to do 3 and 4. And if you multiply that out, you're going to have 18x minus 12y equals 48, negative 48. 20x plus 12y equals negative 28. Then from here, I could have multiplied by 3 and negative 4, but I like to worry about the signs after I multiply. So if you notice, because I multiplied by a positive 3 and a positive 4, I end up with my signs exactly as they were. So one of them's negative and the other's positive already, which is great because then I don't have to change the sign.